So now that we've talked about the create method in the Flowable class, let's talk about another factory method operator that the Flowable class provides. And this is the generate method. So this is the other one. And this one gives you a bit more capability than create does. So the generate operator returns a synchronous, stateless, and backpressure-aware generator of values, whereas the create method does not return a backpressure-aware generator of values. And another thing to note is that flowable generate is quite different from observable generate. Observable generate only generates one thing at a time, whereas flowable can do this backpressure-aware generator. The parameter that's passed here, this generator parameter, is called when a downstream subscriber requests a value. And we'll take a look at this in the example. It's a little hard to visualize till you see it kind of put together, but it's pretty cool. And much as was the case with the emitter that we had for the create method, the emitter that we have here is going to be called, or is going to call on next, on error, or on complete to signal a value or signal some terminal event. One thing to remember with this, these methods should only be called synchronously. Now, they can be called in a background thread, but they should be called synchronously in the sense that one thread should call all the on next events. The same thread should call the on error or on complete event if they need to occur. And they should not be called from separate threads concurrently because they don't have any way to synchronize. They aren't built, they don't have a thread safe mechanism built in. And you should only call these while the method body is executing. And that's handled for you. You pass in this consumer and then the things get done behind the scenes. The generate method returns a flowable instance. This flowable is also cold, which means it only emits elements when somebody subscribes to it. And as was the case with create, each flowable has its own set of items that are emitted to it. So it'll emit the events to each new subscriber. That's in contrast to like hot emitters or hot publishers, where it's generated no matter what, and whenever you join it, you just get what happens to be the latest value. Best way to think about hot versus cold is kind of hot is like the radio station, a radio station where you tune into it and you get whatever song happens to be playing. In contrast, something like a streaming service where you go and each time you subscribe to watch the next episode of Friends or Pennyworth or Game of Thrones or whatever you're watching, you start from the beginning of that and you can stream it from the beginning. And each new person who joins is joining from the beginning, not somewhere in the middle. The parameter, this parameter, the generator parameter, is invoked to emit the given number of events when a subscriber calls request on a subscription. And this is kind of how this works. This is an example we'll look at here shortly, which is example EX2. And example EX2 shows how a subscriber will basically request some number of events. So the subscriber says, hey, I want M request size events, please. Let's say that's 10, just for sake of argument. It could be 5, it could be 10, it could be 100, it could be 1, whatever. And what that'll do then is that'll send a message up the stream to the generator, to the publisher, and it will then invoke this particular consumer to say, please generate the next event for me. And you can see the way this works. This particular example says if we've not emitted all the ones we're supposed to emit, in other words, if the count is less, if the integers emitted is less than the max count, then emit the next value. And you can see we get a next random int, and we emit it through the onNext method. Otherwise, let's call onComplete. And onComplete is going to shut things down. So every time this thing is called, it'll either emit a random integer or it'll say, I'm done. Kind of like end of file, if you will. And so if you say, I want 10 of these things, this method, this consumer lambda will be called back that many times, or until onComplete is generated. So kind of cool. Project Reactor has a create method in the Flux class that works very similarly to this. The main difference between Project Reactor and RxJava is that when RxJava was built, they didn't really have a sensible support for backpressure, and they kind of added it a little bit into observable. They said, that's kind of crazy. So they took all the backpressure stuff, most of the backpressure stuff, I guess all the backpressure stuff, out of observable, and they put it into Flowable. But they split it between two methods. They split it between create and generate. In contrast, when they built Project Reactor, when it was developed, because it came later, they said, let's build backpressure-aware publishers and backpressure-unaware, non-backpressure-aware publishers into the Flux class. They don't have a difference. There's no equivalent to the observable, flowable distinction in Project Reactor as there is in RxJava. So Flux Create can both support backpressure-aware publishers and backpressure strategies. So you can have both of them in the same method abstraction. Interestingly enough, Flux's generator method is like the observable generator method, and it lacks support for backpressure. Other than, I guess it does have, it lacks sophisticated backpressure support. It generates one thing at a time. So there's an implicit type of backpressure there. Java Streams has a generate method that doesn't support backpressure, as we've talked about before, so it doesn't really matter because that's a pull model versus a push model. So that's the end of the discussion of the second factor method operator in the Flowable class that supports backpressure. And this is the one that's really cool because it lets you have backpressure-aware publishers that coordinate with backpressure-aware subscribers to send basically windows of data before the next tranche is requested.